The cast mnemonic device helps us remember which trig ratios are positive in which quadrant. If we take a look at the first quadrant right here, all the trigonometric ratios are positive in that quadrant, which means that the sine, cos, and tan of an angle in standard position within this quadrant, all these ratios will be positive. If the terminal arm is in the second quadrant, so your theta is greater than 90 degrees but less than 180 degrees, then the sine ratio is the only ratio that is going to be positive in the second quadrant. If the terminal arm is in the third quadrant, so that means that theta is greater than 180 degrees but less than 270 degrees, then only the tangent ratio will be positive. Lastly, and without having to redraw the terminal arm and theta, any terminal arm in the fourth quadrant will result in the cosine ratio being positive. All other ratios will be negative. Let's take a look at two examples in which we can further examine this concept. The first example involves finding the sine of 240 degrees. The 240 degrees is a positive angle, which means that it is in standard position, indicating counterclockwise rotation from the positive x-axis. So counterclockwise rotation from the positive x-axis, 240 degrees, roughly lands me about here in the third quadrant. Using the cast rule, cosine is positive in the fourth, all are positive in the first, sine is positive in the second, and tan is positive in the third. If I'm trying to find the sine of 240 degrees, that means I'm finding the sine of an angle in the third quadrant. Well, this ratio is going to be negative. To find the related acute angle in the third quadrant, and remember, the related acute angle is the acute angle that the terminal arm makes with the x-axis. And this helps us because it produces a right-angled triangle with the x-axis. So in order to find the related acute angle here, how do I find this acute angle? Well, I can take the theta and I can subtract 180 degrees. Okay, so my related acute angle is going to be 240 degrees minus 180 degrees. So my related acute angle here is 60 degrees. So in this triangle formed between the terminal arm and the x-axis, this related acute angle here is 60 degrees. And I'll try and draw it super small. This one over here is 30 degrees then, which means I have a special triangle. This y value going down right here is negative root 3. This x value going in the left direction, okay, which means that it is on the negative side of the x-axis, that is negative 1. And the r value is always positive, and that is 2. So to find sine of 240 degrees, I need to determine the ratio of y over r, y being negative root 3, r being 2. So sine of 240 degrees is equal to negative root 3 over 2. This again is verified by the fact that it's a negative quantity, which it should be since the terminal arm is in the third quadrant. In the next example, it says for theta in standard position, and theta is an angle between 0 and 360 degrees, determine theta if tan theta is equal to negative 3.732. Well, if tan theta is equal to negative 3.732, I can find theta by using the inverse tan of negative 3.732 And what I end up with is theta is approximately equal to negative 75 degrees. Well, if theta is equal to negative 75 degrees, that means my terminal arm is in the fourth quadrant, right? Because as you will recall, a negative angle means clockwise rotation from the x-axis. However, this is problematic because theta cannot be a negative value. We see that in the restrictions placed in the question. Theta has to be a positive value. So in order to find that positive value, I have to go from the positive x-axis in a counterclockwise motion, right there. And so this theta right there is going to be equal to 285 degrees. That 285 degrees rotation arrives at the same terminal arm as negative 75 degrees. So one of your possible answers, theta sub 1 is equal to 285 degrees. The reason why I say there's one possible answer is, take a look. If tan theta is negative, well, remember that tan is negative in quad 2 and quad 4. Well, we found the one in quad 4 already. That is 285 degrees, which means there is another possible answer here. And so the other possible answer is to draw a terminal arm in the second quadrant here, and we need to find this theta. So green theta, that's theta 2. We know that the related acute angle is 75 degrees. So then theta 2 is equal to 180 degrees minus 75 degrees, and that means that theta 2 is equal to 105 degrees. So there are the two possible answers. Theta could be 285 degrees or 105 degrees.